When you start using CAM within Fusion 360, it's good practice to start out with something simple. Maybe mill a pocket and drill a few holes, but not much time goes by before you need to machine a little bit more complex shapes. This video is about getting you started with machining those shapes. I'll share my shortcuts to get you started with 3D machining. Hi everybody, my name is Lars, Christensen, and thank you so much for taking the time to watch this video. Now, if you're brand new to CAM within Fusion 360, I'll recommend that you go down in the description area and click the link to How to Learn CAM within Fusion 360 Basics series. That one will show you how to set up your origin, it will show you how to machine pockets and drill holes. In this video, we're going to take it one step further and get started with some 3D machining. So we're going to machine some surfaces. But before we get to it, as always, I really appreciate your comments and suggestions down in the comment area. I know many people read them. I can assure you that I read them all. And if you like this video, do me a favor, hit the thumbs up. If you don't, hit the thumbs down. And if you haven't already, I would truly appreciate if you will subscribe to the channel. Now, let's get going. So first, let's talk about the difference between 2D and 3D machining. So if I go up here and hit the drop down under 2D, you will see we have operations like a facing operation. This will let you create like a planar datum on top of your part. Now if you go down to the 2D contour, that will let you machine around your part. You can also do something like a 2D pocket, and even like a drilling operation would be considered 2D. What a 2D operation basically is that the Z-axis, or the head that is moving up and down, pre-positions before your X and your Y, or the table on your machine, starts moving. So, why 3D? Why is there so many 3D toolpaths available in the drop-down inside of Fusion 360? And if you ever go in and look at the Geometry tab, the settings are a lot different than what you see for the 2D. And maybe more important, how does a good 3D toolpath look like? What are we trying to achieve? Well, to explain that, I think we got to do something most guys like to do. Let's go car shopping. So let's talk a little bit about what we want here. So what we really want is a toolpath that follows our 3D surface nice and smooth. So if you, for example, take a look at this 2007 Honda Civic, you can see that the outside is designed primarily for aerodynamics. Even if you're looking inside of it, you can see that kind of the dashboard is all curved. You know, that is how most cars are, maybe except from Jeeps. You really don't find any kind of radiuses on a car. It's all curved surfaces. Now, one of the better ways to look at a curved surface is if you're looking along the side of this car, and it's not even a sunny day here in upstate New York, you can kind of see how the sidewalk and the road are reflecting on the side of the car. And that is those different curves along the car that we want kind of like our toolpaths to follow. But before we start talking about specific toolpath, maybe you should just touch a little bit on tooling. So when you hit the drop-down menu for 3D machining, you will see that there also here is a adaptive clearing. Now the cool thing about adaptive clearing is that you can actually machine with pretty much the full length of the flute on your cutter. What this does is limits the amount of step downs you have to do, but puts a lot of pressure on your cutter. Now, many times people recommend that you're using a bullnose end mill for this, and a bullnose end mill is really just a flat end mill with a little bit of a radius on the sharp point of the tooth, and it just makes the cutter a little bit stronger. But of course, if you don't have a bullnose end mill, it's fine. You don't have to go out and buy one. You can definitely use a standard flat end mill. Now, when it comes to our finishing operations, you will always use a ball end mill to finish your surface machining. So if you're looking at the section view here, you will see the adaptive clearing going all the way down to pretty much the whole flute length, and then it will start working its way out and kind of like step up to creating the shape, roughing out the shape of our 3D contour. Now, many times when you're machining things like this, you will actually use both a roughing operation, semi-finish, and then finish, multiple semi-finish sometimes. So after our adaptive clearing here, you will see that I'm coming in with a semi-finish operation. And really all you're doing when you do semi-finish is you're leaving a little bit more stock to leave, and then you can make your step over a little bit bigger. If I'm zooming in here, you can actually see that we kind of like get some cusp created between the step over. So of course, when we come into our finishing operation, all we're gonna do is we're gonna make the step over smaller, and then you will see that it kind of like cleans all that out and leaves us that beautiful ending surface. Now, many people ask me, what is the right amount of step over? Well, it comes down to two things. It comes down to how nice of a finish do you need and how much time do you have. The fact is that the smaller you make the step over, well, the longer it's going to take to machine. And remember, when it comes to feeds and speeds, I always recommend that you're using the feeds and speeds from the tool provider that you're buying them from. That is always the best starting point. So let's talk a little bit about toolpath. If you hit the drop down in 3D machining inside of Fusion 360, you will see that there's a lot of different types of toolpath to pick from. Now today I will give you the 3 that I think you need to know about, and I think covers most of surface machining that you need to use. So if you look at this model here, you will see that the green metallic is what we want to machine, and this part here is kind of horizontal flat. It's very like nice curved, no crazy steep mountains, peaks on this one here. So here we will use what is called a parallel tool path. Now you can almost say that these tool paths resemble cars. So you could say that this is kind of like a mid-size, pretty standard car, nothing too crazy, and it will perform nicely going across the surface. And of course here the tool paths are assembled with the blue lines. Very nice, smooth going over. Now if we expand the model a little bit, you will see we get more green metallic surfaces, and some of them are really steep. Well, here the parallel cut or mid-sized car kind of starts failing on us a little bit. You will see on this vertical wall we don't even get any blue lines, and over here, well, the toolpath is doing a little bit of a funky move, and this will definitely leave material that needs to be machined in a second operation. So for these kind of steep wall scenarios, you might want to upgrade your mid-size for something, well, a little bit more four-wheel drive maybe. So here we're going to go to the contour toolpath. Now when we apply the contour toolpath here, look how nicely it does on the vertical surfaces. It kind of goes in the reverse direction of the parallel, but it does a really nice job, very unified, going all the way down on the vertical surface. However, when we're looking at the top of our part on the horizontal portion, suddenly the contour is not doing so well here as our mid-size did. So, you know, honestly, what we've been doing in the machining industry for the last, I don't know, 15, 20 years is we combine the two. So many CAM packages does exactly that, that you will put a parallel on top and you will put a contour on the steep walls, and you actually get a pretty good result. The only thing you get is maybe a little bit of a blending issue between the two, but you can work with that with some of the other finishing toolpaths that exist in the drop-down. Play around. Let me just expand the model out a third and last time. So now we really have a model here with a lot of curves and different shapes blending together. And the last toolpath I want to show here is almost the best of the two worlds, and that is the scallop toolpath. Now what is neat about the scallop toolpath is it really takes the outer edge of our model and is kind of collapsing it towards the center of our part. So if I simulate it, you will see how the tool is kind of collapsing from the outside towards the center of the part, and it gives us a really nice unified kind of tool path. So here you have the three different tool paths. You got your parallel, your mid-size, kind of like going over a somewhat horizontal, nice surface. You got your contour that is really good when we kind of like go more steep angles, and then play around with the scallop and see if you can get a good unified between that, if that is the type of surface that you need to machine. Alright, so it's time to look under the hood for some 3D machining settings. So to machine the green metallic surface on this model, we will go up and hit the drop down for the 3D, and we are going to select a parallel cut. Now, just like when you're doing 2D toolpath, the 5 tabs in the options for 3D toolpath are the same. So you don't have to worry about that. So that means that the first tab is always where you select your tool. And as I said earlier, we will go with a ball and mill for this. Now, here's my first rule. Whenever you're machining a 3D surface within Fusion 360, select your tool, but then hit OK. I know you have not been in tweaking any settings yet, but we don't have to. Start out with just hitting OK and see what the software gives you. As you can see here, one of the major differences between a 2D toolpath and a 3D toolpath within Fusion 360 is that in a 2D toolpath, you will pick all the geometry to be able to get something to machine. But in 3D machining, it has already been selected. What we're going to do from here on is we are going to adjust the toolpath. So that's why just select your tool and hit OK and see what you get. Now, when we're looking at this toolpath, we can see that the parallel, again, is not performing great on steep walls. You can kind of like see these blue lines. They have some big dips to them and major step over between them. That doesn't mean that parallel is necessarily a bad toolpath for this one. Actually, if we rotate it 90 degrees, it would actually be pretty good. So I'm going to do that by going back into the parallel. I'm going to right click and hit edit. And now I'm going to go over to the passes tab. And here you will see that I have a pass direction. So if I change that from 0 to 90 and hit OK, let's see what we get now. And that is probably the best advice I can give you when you're working with 3D machining within Fusion 360. Only change one thing and then hit OK and see what you get, and then go in and change again. Don't go in and just change a bunch of things because it's hard to figure out exactly what is happening. So now you will see on the metallic green surface, we actually have a very nice machined surface right here. But we got to talk about selection, because we have just right now selected the entire part, and we actually just want to boundary it within the green metallic surface. So how do we do that? Well, let's get into our geometry tab. So I'm going to right click and hit edit and go to the geometry tab. Now I'm going to start from the top and kind of like working my way down, showing you the things that you need to be aware of. First of all, your machining boundary is set to silhouette. Now let me just go normal to that top surface here. So we're looking down at it. That is what silhouette means. What Fusion is doing, it's almost like casting a light from the top down on your part. And anything this light hits, it is going to machine. Now there is some different options in here. We'll get to those in a second. You will also see we have tool containment. So what we can do in here, we can control how our tool is going to behave within that silhouette. So you can set here tool to be on the inside boundary. That means that the tool will not move past that silhouette that is being thrown on your model. We can do tool center the boundary. That's what we have right now, meaning that the center of the tool is allowed to go right up to the edge of our part. And then the last one is outside boundary, which means we will let the tool going past it. Now, I don't use outside boundary very often. I'm just going to leave it on tool center boundary. So the first option I want to show you to how you can contain your tool path is going down to the bottom here where you have an avoid touch surface. See, right now when we are casting a silhouette on top of the part, you will see that we machined the whole entire part. But if I check avoid and I check these two surfaces here, just select these two and hit OK, you will now see our toolpath is not touching the top of our part anymore. It has now been contained within, so it's not allowing touching that area. That is one way to control the boundaries of the toolpath. Another one that maybe is a little bit more preferable, let's go back in and edit the toolpath again. And I'm going to go back to the Geometry tab. I'm going to unselect those two faces. I'm going to unselect Avoid Touch. So we're back to where we were before. Just resetting back. You will now see again the toolpath are touching up on the top where I don't want it to be. Well, if we go back into the Geometry tab, instead of using Silhouette, we can use Selection. Now, when I hit selection and I hover over my part, you will see that the software is trying to pre-select the chaining for it, but I can't really get only that metallic flake. It keeps on selecting one of the top faces up there. But of course, there's always a way around that inside of Fusion 360. I'm going to select the wrong kind of chain here, and you will see that I get this green boundary box. Well, if I select that boundary box again, it turns red. And now I get the selection manager just like you can do within 2D. So now the blue edges is what I need to machine. So I'm just going to go ahead here and select them. And now you will see that I have defined that area within I want my toolpath. Just remember, you have to hit this little green plus. Don't hit enter. Hit the little green plus down here to get it to stick. And now you will see that we actually get that. And when I hit OK now, so if I go ahead and simulate it, you will see that we have a nice parallel toolpath and it's only going up right to that edge of that surface. So if we take a look at the simulation here of our tool, you will see that our ball end mill is touching on the side here. But what actually happens when it comes to this edge, it actually continues right up to the center of this edge here because we use tool boundary center. There's actually another option in here that you need to be aware of. So let me go back into the parallel toolpath and we go to the Geometry tab. We have selected our chain. We have the tool center on the boundary. That's why we see it going right up to that edge. But if I select contact point boundary, the software is actually smart enough to know where it is losing contact with that surface and it will stop there. So let me hit OK and show you what I mean. With that contact boundary selected, you will actually see that the toolpath finishes right when the ball end mill is letting go of that edge. So just be aware of that setting is in there in case you don't really want the center of your end mill to hit that edge. So let's bring up our model from before and go through these settings step by step. So I'm going to go up and select my 3D toolpath. I'm going to select the parallel again. I'm going to go ahead and select my ball end mill and then hit OK because I really want to see what the software comes up with before I go any further. Now I get the right direction on my toolpath. This looks pretty good. But you will see that because of my settings, I'm not machining the full depth of the green metallic surface here. So let me go in and edit that so we can take a look at what we have in the Geometry tab. So the reason for that is because our tool is sent to center boundary. Now let's turn on contact point boundary, because that will actually override the tool center on boundary. I'm going to hit OK. And you will now see that my tool path is going past and all the way down to that edge. But it's actually going a little bit deeper than I want. I don't want it to touch this surface, and I don't want it to touch this surface. So let's go back into our setting, go to the Geometry tab, and select Avoid Surfaces. I'm going to select this surface, and I'm going to select this surface. Let's hit OK. And now we have a really nice surface where the tool will come down right to where it's touching on that edge and will go back and forth. This will give you a very nice 3D surface. Now the last tip I want to leave you with here is for this scallop toolpath. Remember that I said that it kind of collapses from the outside and in towards the center of the part. It really creates a nice step over. But there is a very powerful tool in there. Now, if I'm going to go out here and take a closer look, you will see that we get some interesting bumps in this corner here because it's collapsing from the edge towards the center, and the software kind of have to make some calculations there. You will also see, if you look up on the top here of the handle, you will see as it's collapsing in here, we kind of like are left up with two kind of islands right here, or eyes looking at you. And the space between here will probably leave a little bit of material. There's a very neat way we can work with a scallop toolpath. Because it's collapsing from the outside in, we can actually create sketch geometry and then use that as the edges that collapses in. Let me show you what I'm talking about. I'm going to go over to the model side, and I am going to open a new sketch on the back side here. Now you could here just creating some lines, some arcs, even some splines. But what I'm actually going to do is I'm going to offset the command. I'm going to just hit the S key here and hit offset, so I get the offset command right here. And I'm going to grab this edge and just start dragging it out. Now notice this area right here. See how that is kind of like curved in? Well, because I am offsetting it out, I can actually eliminate that whole edge pretty much if I just go far enough out. Right? So now it's a line and it doesn't have that development, because that development is what's going to lead the collapse. So I'm just going to move out here. So let's see that it gets straight here. It will leave less for it to collapse. And I'm going to hit OK. And I'm just going to stop the sketch. I can show the sketch so we can actually see it. And let's go back into CAM. Now, of course, right here we're getting some red marks because we just updated the geometry of the model. But what I'm going to do is I'm going to duplicate the one we already had. And then I'm going to go into the duplicate or the copy. I'm going to edit it. And you will see that when I go over to the Geometry tab, instead of using Silhouette, I'm actually going to, again, choose Selection. Now I'm going to select my sketch geometry, and you've guessed it right. When I hit OK, now the collapse is coming from this sketch geometry towards the center of the part and not just from the edge. So what does that do? It creates a different type of collapse in these areas here. And you will see up on the top, we now have a clean cut back and forth. So be aware of that you can control the scallop toolpath with other geometry, controlling how it's going to collapse in. So just to point back here, we can see this edge here, and when I hit the scallop, you will see that we now got a different one. Now you could change the sketch geometry a little bit, play around with it, and you will get different result. But that's an important thing to know about the scallop toolpath. So I'm gonna leave you with this. I know we did not cover all the options within 3D machining, but I believe that this will give you a good starting point to venture down that path. Also remember that when you're sitting with your model, it's going to have some different surfaces, meaning you're going to get some different results. And when you get a little confused or maybe a little irritated, come back and rewatch this video to kind of like get reset of the basics of 3D machining. Now you let me know on the thumbs up or thumbs down, or leave me a comment below what you think of this video. And if you haven't already, go and click the link to get your free CNC Handbook. There's a lot of great stuff in there. So, until the next time, have an awesome day.